Hey everybody, this is Larry. This is day 21 of the June Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's farm. It is very hot here today, so I can't even think. But yeah, I have some clips from the 50K that I did yesterday. But not today. It's very hot. I'm gonna finish this part of my apartment. I don't have a good AC. I have a fan, but it's just very hot. I don't know. Not even that hot. Maybe just humid. I don't know. Or maybe it is hot inside. I don't know. So it's a little hot. I don't know. Either way, without further ado, today was mostly a rest day because obviously. So yeah, let's take a look at today's problem. We have 3085 minimum deletions to make string K special. Oh, I hope you hit all the buttons, and also, oh yeah. I always forget about this, but I finally hit 50,000 subscribers. Thanks everyone for watching and support and everything. Yeah, it's been many years now at this point, so I don't know what to say. But if it just helps like a couple of people, it's fine. I don't know. It's great. Yeah. All right, let's take a look. We have you're given a string word integer k. The word is K special with frequency of I and J is less than K for all indexes in a string. Okay. Here, okay. Return the minimum number of characters you need to delete to make word K special. Okay. I think the first thing that I would say, first thing I noticed, and this is actually the same thing we talked about yesterday. We watched that video. Of course, you probably watch every video, right? No, but yeah, and that is whether the order matter. And here, the order doesn't matter, and the indexing doesn't matter as far as I can tell, right? So what I mean by that is that, and you need to know frequency. So the first thing I would do is just wrap it around a frequency table. You could put this in a frequency map or whatever, right? Okay, and then now, what do I remove? I think now it is a sliding window on the frequency, right? Initially, I was going to say, and maybe you could still think about it in that way, but then after that, it was an extension of it. But the idea here, let me go over my thought process. I mean, it happened really quickly, so I didn't really talk about it. But my first idea was, okay, well, there are two ways you can do it, or at least two ways, but two, immediately off the bat way of thinking about it. One is you remove the fewest character, right? For example, if you have, I don't know, just like A, a lot of B's. In this case, you only have to remove one, right? You remove A and you're done. Another similar thing is if you have same thing, but instead you have like A, C, D, E, F, G, H, I, J, I don't know, just long enough, and maybe reduce this a little bit so I don't have to list all of them. But you can see that we just removed the most frequent one. That will be good, right? And this is only 6, and then now, and I didn't even talk about what K is, but for some small K, you get the idea, because we just said K is equal to 0, K is equal to 1 or whatever, right? Or 0 in this case, right? So some small K, but you get the idea anyway. That's the point of illustrating it, right? So you have these two cases, and then immediately my idea jumped, honestly, to okay, now you do a sliding window, right? Because here now you look at the frequency value, and maybe we can print it out real quick for illustration. Fingers on the wrong keys, right? If you run it real quick, and I don't think that these, okay. Yeah, it's not super valuable only because the inputs are not very good. Maybe this one's okay, but you get the idea. You have 5, 1, 2, 3, and of course you wanted to sort them so you have it in order. But then now you have sliding window, right? Because now you're given this K, you have this array, and you want to know that the smallest and the largest is K. So that means that I didn't even look at N because N doesn't even matter because this has mode 26. So actually, I mean, yes, you can do sliding window, and probably the way to do it, to be frank. But because the 26 range, you can also do some 26 square type, solution, and also be good enough because 26 is a small number, right? where 26 is the size of the alphabet or alpha or whatever you want to call it. And yeah, and that should be good enough because then now you remove everything that's outside that range, right? Like if you have 2, then you have, that 1, 2, 3 is good, so you have to remove everything outside. Same as here, and then I guess here, right? And then you remove 1 and 2. So that's basically the idea. So then now we have maybe this. You can say, I think we have to convert to a list. So it's very hard. I need some water. But hopefully that, this is, you see where I'm going with this. I am going to do the sliding window way, but even alpha square will be fast enough. So yeah. Gotta keep yourself hydrated with that microplastic, But yeah, okay. So then now this is, like I said, sliding window. N or total maybe is equal to length of word, right? Maybe let's just call it N actually. And then maybe best is the most step. Best we said N because that means removing every character, so it'll never be that'll never be the answer, but we'll min it down, right? So then here we have a regular sliding window, right? In range of length of 3, and then here, yeah, just if something like if v of right minus v of left is greater than k, or while this is the case, then left increment, right? And that's it. I did miss some stuff. I mean, you could do a for loop to sum it up, but you can also do it with prefix sum if you want. So maybe it will be alpha cube or something, maybe, or whatever. But here, by now, then we know that v sub right minus v sub left, it's going to be less than equal to k. So then now that means that we want the sum inside, right? And you can do a prefix sum, but you also just keep track of sum that's inside, right? You could do prefix sum, you could do a loop here. But for example, we could say inside sum is equal to 0. And then anytime, and this gets incremented, right? So that means that we want inside sum, we want to increment v sub right. And then now we have this, and then inside sum is going to be inside sum, subtract v sub left. And then, yeah. And then now best is equal to the min of best n minus inside sum being the number of characters that are inside the window, if you will. And that's it, I think. I mean, maybe I'm off by 1 or something, but which happens a lot, which is why I say that a lot. But should be right? Okay. So why is this? Well, it'd be funny if I misunderstood this problem altogether. Because it has to be the entire word, right? Okay. So just want to make sure. Okay. Huh. Why am I getting a wrong answer? It's a little bit sad. We'll see. Hopefully it's just a typo. So 2, we put 3 because this removes 5. This removes 6. This removes 3. What is 2? Maybe I'm. Oh, I did mess up actually. Huh. Okay. So this idea is that 5. You reduce them to 3. Not, you don't have to remove all 5, you only have to remove 3. So okay, so I was wrong there. Everything smaller than it we have to remove, but everything bigger than it, we can just bring it down to the biggest number. Okay. We have to do some maths though, but that's more annoying but also easy to do. Because for my sliding window, and this is still a sliding window, but I think the math is a little bit trickier, right? And I honestly, okay. I mean, obviously I was just wrong a little bit, but still very close to right. And that's why you kind of have this visualization and me visualizing this, right? So maybe we write like smaller is equal to 0, right? So then now only when we shrink outside, we write smaller, right? So then now it's n minus smaller, and then we have to figure out how to bring the things from bigger to and honestly at this point, if I was doing a contest, I would just write a for loop, right? Just to be clear. Yeah. Or I probably wouldn't have done it this way. Which one is more natural? I mean, alpha is 26, so I am going to do it the quote unquote the optimal clean way later. But I want to at least get one right answer to show you the other way, because I think it's just easier to do, right? It's just for left in range of length of v, for right in range of length of v, starting from left, and then maybe and this is alpha cube even, but which is fine, right? So for I in range of length of v, if what's it? If v of I is less than v of left, then current added by v of left, because we're moving them all, right? Else v of I is greater than v of right, then current we added by v of I minus v of right, because we only have to reduce it to v sub right, right? And I forgot some stuff, which is that if v of right minus v of left is less than k, right? Just to be clear. Or less than equal to, I think, sorry. Then now we do this loop, and then best is equal to min best current. And then that's it, hopefully. Right? I mean, that's pretty straightforward. I didn't want to do it this way. But, ooh. Apparently, even this way, I'm very wrong. Why is that? Did I mess something up? These are the numbers to remove. Which one? Man, today is just non-stop action. Okay, fine. K is equal to 1. I output 3. Why would I output 3? It's for 4, remove 1, remove 2 is 3. How do you remove only 2? Oh, that's interesting, actually. Because then now you want to reduce to 6 to 5. So actually this is going to be left plus k. That's more precise. If we want to set left bound is, yeah. And actually in that case, we don't even need this right. We can use, right? So there's definitely a lot of, it's definitely trickier than I expected, to be honest. And then we don't need this anymore, I suppose, right? In fact, this is much cleaner than the way that I was writing it, but maybe more wrong. Oh, because the min doesn't have to be v sub f. That's probably why. I don't know if that's why, but it's probably why. V sub left. Oh, also this is, well, I think what I said is maybe, no, I think this is right. Yeah, but this is actually much cleaner, and this is also, oh, I kept the print in there. This is alpha square, like I said, but I was thinking more about sliding windows. That's why I didn't think of it this way. Somehow the print statement was faster. That's very weird, but okay. Anyway, so this is all of alpha square. I'm not going to go over it that deeply. Hopefully this makes sense. But essentially, that's what we want to do here, right? So here with the sliding window, we want to say the smaller is all the things that up to here, and then the larger is all the things up to here. And the idea behind this is, and the reason why I want to explain it, and you don't have to, feel free to just hit the like button instead. Is this minus smaller and minus bigger change, right? So here, yeah. And actually, you could even pre-calculate this, I think. But making sure that we don't make the same mistakes before, which is that we actually want v of left plus k, right? So that means that everything bigger than v sub right is, you know, is greater than v sub left plus k by definition, because this is just a rewrite of this function, right? Minus k on, plus v sub left on both sides, and then you have this side, right? So everything to the right of v sub right, v sub right is, well, technically inside this loop this is true. So afterwards, v minus k, v minus v sub right minus v sub left is less than or equal to k, but that means that v plus 1 is bigger than this one case, right? So I just want to, that's the invariant, right? And as that invariant, then now another thing, and this is actually where you need prefix sum, so I lied about not needing prefix sum apparently. Because the idea here is a geometry problem. And it's something that comes up on harder problems here and there. It's something that I try to think about from time to time. But okay, so let's say you have, let's say you have some numbers, right? Let's say you have, I forget, let's just make them up. 1, 2, 3, 5, 7, 9, 11, something like that. And k is equal to 2, or whatever, right? But here, let's just say we did this, right? And then now, we want to say, okay, this is the window. 1 is the smaller number, so 3. So everything up here is going to be bigger than 1 plus 2. So then, but we want to bring everything to the number, we want to bring everything from the right side to 3, right? So that means that this is minus 2, this is minus 4, this is minus 5. I did the math wrong. 6 minus 8, right? So then how do you do all this in one operation? Well, instead of doing a for loop, I mean, right? And the idea is visualization is how I want to think about it. And what I mean by that is, okay, let's draw this out, right? So you have 1, and then not to scale, I'm drawing but freehand, right? 2, 3, 5, 7, maybe one more because I cannot fit. Okay, you could kind of see it, but I'm terrible at this, right? And then the idea is that, okay, we want to bring them down to 3, right? What does that look like? So this is 3, this is x is equal to 3 or whatever, y is equal to 3 maybe, right? And then the idea here is that, okay, to bring them down, that means that this is 2, this is 4, this is 6, right? And if there was another one, it'll be 8, but you get the idea. So then now, if you can't look at it just from a visualization kind of point of view, then how do you get the 2 plus 4 plus 6? Well, it consists of 2 components, right? One is this component, which is easy to calculate because it's just 3 times 3, right? And then the other is where we get the prefix sum from, because we knew the sum of the green portions, and the green portion do overlap with the blue portions, just to be clear. If we take the green and then we minus the blue, if we take the green and we minus the blue, then you get the red, right? And that's basically the idea behind that. And of course, this is way overkill for this problem, just to be, wrong button. This is way overkill for this problem, to be honest. But I just, this is an idea to get it cut down to O of alpha, right? On this part anyway, because this is going to be dominated by O of n. And I even did the sorting, so, but the sorting is alpha log alpha, right? Because you only sort on the values. And you can, in theory, do a bucket sort or something. Only 26 items, I don't know. Something weird, an F, right? But anyway, so with that in mind, then now we want to do a prefix sum on V, right? So we want to say prefix sum on V. Naming things is hard. I just got X. Right? And then now we know, bring it back here, and actually just v sub right plus 1. So everything we want And maybe we could do a suffix sum, really. Maybe that's a little bit cleaner, but so we want the sum from v right plus 1 dot 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 all the way to v of n minus 1, right? Or not n minus 1, but alpha minus length of v minus 1, right? Because n we used it for the length of the word, so yeah, it's a little bit different. But yeah, and so that's basically it. Which is if you, and today I'm not going over prefix sum. Like I said, this part is advanced, so extra credit. But I just want to say like prefix of n, or not n again, not n, length of v minus prefix of right is it right or right plus 1? I think it's right plus 1. So we want to remove the sum from v to right. So yeah, right plus 1. It's very confusing though. Again, I'm not going to go over it though. But yeah, this is the bigger part. Is equal to this. So that's the sum minus, minus, oh no, sorry, did I say minus? We already did the minus. Multiply by the rectangle we have, which is going to be v of left plus k is the width times the height. Oh no, this is the height, sorry. This is the height, and then the width is just the number of elements, which is going to be length of v minus right plus 1, I think. This is... And that's it, hopefully. Alright, well, I'm going to have some triple quotes right now. Excuse me. Alright, apparently it's very well. But yeah. Bigger is the number of operations that we do. No, that sounds right. I mean, this is ideally right, but let's take a look. I don't know anymore. I'm just double checking real quick, but it seems right. It should be over. Bigger is 12. That's not right. I mean, that shouldn't be 12. Is my prefix sum wrong? I mean, you're removing more characters than they exist in the word, so that's definitely wrong. But what is prefix sum then? Did I do this wrong? I mean, apparently. Out of shape, out of practice. 0, 1, 3, 7. That sounds roughly right. So then you have length of v, so 7 minus right plus 1. Okay. We want to subtract. Oh, I'm dumb. What is going on here? I forgot some subtraction, right? Did I? What's going on here? This is the sum. Why am I multiplying? I don't know. So this is the total area. I did say I said subtraction and I confused myself a little bit. But yeah, that's the total area. This is the rectangle. So then we do, and at least this is good, right? Still not right though for some reason. So that's a little bit sad. But let's see. I blame it on the heat. I can't think in the heat. Alright, 1, 2, 3, 5 are the numbers. So we do 0, 0. So you keep 1. This is going to remove. Yeah, big is definitely wrong then, right? Because here the prefix sum should have been 11 minus 1 maybe. So that's going to be 10. 10 minus this thing, which maybe is too big. but this should be 4 or something. But clearly, this is not 4. So I'm definitely off by 1, I suppose. So this part is definitely right. Maybe this part. Man, math is hard, isn't it? My ideas are right, but man, I've been just trouble executing. All right, print it out. Or even just this, right? Extra parens, I guess. Alright, 0, 0, 1, 2, 3 is high. Alright, we want to change them to 3. Okay, so if we have this number, k is 0 to 2, we want to choose 3. So this should have been 2. So maybe this is actually close to right. But because we want to choose 3, right? So that means that bigger should have been 2, but bigger is 1. Yeah. So something's a little bit off. It is not 3 numbers, that's for sure. It's 1 number. So this one is definitely wrong. So just minus, right? Oh, I see. My right is not correct. I think the idea, because here there's this. So this is why you have to check your invariants. The invariant here is that, well, v sub right, and I was wrong on this, just to be clear. V sub left is equal to, but that does not mean that v sub right, the following line, really, right? This one is not true. Yeah, this one is not true. That's basically the problem. Because here, for example, we have 0 and 0, or 1 and 1 or whatever on a sliding window on this thing. Sorry, this is the visualization. We have this thing. The sliding is on 1 and 1, but then it thinks that 2, 3, and 5 are on the bigger side, but it's subtracted from 3, which is why this returns a negative, which is not what we want. So that means that we have to do some other thing. Well, I mean, I think sliding window is still fine, but that means that we just have to adjust the sliding window, which is that instead of incrementing right every time, we actually want to increment left every time, was the way of how I set it up anyway, right? So we actually want to set something like this up. And then now maybe you can rewrite this as smaller, right? And then now, while this is true, we can say right increment by 1. And then now your invariant is such that v of right minus v of left is greater than k. Or actually, I messed this up. While this is true, we increment right. So that means that here, now this is true, right? This is true just by definition of invariant. And now that this is true, we want to sum from this now. And then the prefix, I think this now changes to here. And is this right plus 1? I think this is just right. Maybe I'm off by 1. Oh yeah, now that we go the other way, we have to check. All right, that's not great. Let's see. I guess we would have to print this stuff. Now we want left, right. Left, right, so 0, 1. For k is 0 to 0. Okay, so that means that 2, 4. Okay. Must have been off by one on one of these. The smaller should be right because it's just trivial to. Oh, smaller is wrong. Should be this minus 1 because it doesn't include it, but that's fine. That's an easy fix. I don't think that changes it though. I mean, it changes the answer, but not to correct. Maybe this one, somehow. But yeah, but here now you want 0, 3. So that's 0, 1, 2, 3. That okay. So then now it takes from the right and to what is that math? That math is from 0 to 3. Smaller is 0. Okay, 2 is bigger. Bigger is right. Bigger is right because we removed 2. Oh, I think this is wrong because we're directly comparing smaller the number we remove and bigger is the number that we move, so we don't need to and subtract that anymore. I don't know how we got right for the other ones. Anyway, my apologies. Clearly a lot of silly mistakes to happen. But I think now we got it right. Sliding windows are tricky sometimes, right? But yeah, I mean, this is, like we're slightly faster, but not that much faster. Like I said, alpha square and alpha is not going to be that much faster. But I think, this is all for alpha. It's a fun exercise. You get to use this, the prefix sum, and crazy maths. It's not that crazy, but it is definitely not needed. But yeah, that's all I have for this one. It's not a half an hour problem if you just did it the silly way. And now I'm curious how I did in the past. Apparently I got it wrong in the past too. Probably the same way with the same wrong answer. At least I'm consistent from a year ago. And then I just did the left-right thing. I didn't even optimize it out. In fact, this is, I guess that's fine. And then I kind of maybe optimized it in the past. Yeah, and then I optimized it in the past. Actually, this is like the same code I wrote today. That's crazy. Isn't it crazy that once you once you know what you're doing, all your code looks the same. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Have a great weekend, everybody. I'm going to go into the AC. See y'all later and take care. Stay good, stay healthy to your mental health. And yeah, see you later and take care. Bye-bye.